Lesson 51, 9-2, Simplifying Rational Expressions. We're continuing on from yesterday. Yesterday we had Lesson 50, 9-2, Simplifying Rational Expressions. Today's expressions are a little more complicated. What you'll need to do today is you're actually going to have to simplify each expression, and you will have to find the excluded values. So 2 steps to each problem here. The first thing that you would want to do to simplify first. Now when you simplify, this top part is simplified. The denominator is not simplified. What you'd want to do is you'd see that a, your a value, is not greater than 1. So you'd want to go ahead and go into factoring right away. The top part is simplified, so we have x minus 4. Your trinomial is minus plus. Therefore, inside both binomials, you'll wind up with minus minus. So we have x minus and x minus. Now remember, you need to figure out what has a product of c that would have a sum of b. So what times what is going to give us 24, and when added together will give us a sum of negative 10. Well, negative 6 times negative 4 would give us positive 24 and the sum of negative 10. Now looking at this problem here, you can go ahead and simplify, and we would cancel out x minus 4 and x minus 4. Whatever is done to a numerator should be done to a denominator. Therefore, simplified, we'd wind up with 1 over x minus 6. To solve for the excluded values, it's easiest if you use the factored form. Use your factored form, set both binomials equal to 0, and then solve for x in both problems. And when you solve in both problems, you'd find out that your excluded values would be 6 and 4. If you were to actually plug in 6 for x here and work through it, you would find out that it would give you 0. And remember, we do not want a denominator of 0. You cannot divide by 0. Example 6, looking at our problem here, our numerator, we can go ahead and actually we can factor something out of this. We should be able to factor out a 3. When you factor out a 3, you're left with r minus 2. So take a 3 out, we're left with r. Take a 3 out of the negative 6, we're left with negative 2. Factored out a 3, simplified that. Now, here's another thing that we had another lesson on, when we had r squared minus 4, and you could take a square root of a binomial. So when you have a difference of a squared minus b squared, it is also written in the form a plus b times a minus b. So in this case, you would have r plus 2 and r minus 2. Your positive 2 times negative 2 would give you that negative 4. Now, we'd also be able to simplify off of this problem. We would be able to get rid of r minus 2 and r minus 2, leaving us with 3 over r plus 2. There's your simplified form. Again, for excluded value, use the factored form on the bottom. So set both of those equal to 0. And when you solve, you'd find out that r cannot be 2 and it cannot be negative 2. Moving on to example 7. In example 7, you have 2 trinomials. So to simplify this, you would need to make them into 2 binomials, pair of binomials, and then when FOILed, they would give you the trinomial. So here we go. We have minus plus. The minus plus would give us minus minus inside our binomials. What has a product of c that would have a sum of b? C is 35, so negative 7 times negative 5. When added together, it would give you that negative 12. Same concept for your denominator. We have minus minus, which would be plus minus. Has a product of c. 3 times 3 and 7 would give us that. So we need to determine, well, we need to come up with negative 4. if we're using 3 and 7, we should have a positive 3 and a negative 7. So when you add them together, they give you that sum of B. This problem, again, we'd be able to factor out k minus 7, k minus 7, and the simplified answer would be k minus 5 over k plus 3. Excluded values, again, using the factored form, set both equal to 0, and you would solve for k in each instant, and you would find out that k cannot be negative 3 and k cannot be 7. This would make your denominator 0, so those are the excluded values. As we get to example 8's a little more complex. If we look at example 8, the first thing in example 8 I'd want to do is factor greatest common factor out. In the numerator, I can factor out a 10m. When I factor out a 10m inside my binomial, I would be left with 3m squared minus m minus 14. The denominator, you can also factor out a 10m. When you factor out a 10m, you're left with 5m squared minus 4m minus 1. Again, if you were to use your distributive property and put your 10m back into your trinomial here, you'd wind up with your trinomial you originally started with. Now, looking at this problem, it is still not simplified. Reason being is you still have a trinomial here. The problem is we see that our a value is greater than 1. When your a value is greater than 1, we've been factoring by grouping. So when a is greater than 1, we factor by grouping. In order to factor by grouping, you take your trinomial, 3m squared minus m minus 14. I'm going to deal with the numerator first. You have to find the product of AC. So a is 3, c is 14. We wind up with 42 or negative 42, either way you look at it. You look at your binomial here, it is minus minus. Sorry, your trinomial is minus minus. So therefore, you would wind up with plus minus. Now you need to think of what has the product of AC, so 42, that would have a sum of B. We want to get negative 1. 6 times 7. 6 would have to be positive, so you'd have a 6m. 7 would have to be negative. So when you add these together, positive 6 minus 7, we get that negative 1m. So I write out the equation 3m squared plus 6m minus 7m minus 14. Here's where the grouping comes into play. You group your first two terms, 3m squared plus 6m, plus, this is really saying plus a negative 7m, so plus a negative 7m. So I'd group negative 7m minus 14. I need to factor out of each binomial. In the first binomial, I can factor out a 3m. When I factor out 3m, I'm left with m plus 2. In the second, I can factor out a negative 7. When I factor out a negative 7, I'm left with m plus 2. That whole goal of factoring by grouping is to get these two binomials the same. When that happens, I can write them as two binomials. So I have 3m minus 7, 3m minus 7, and the m plus 2. Again, if you were to actually FOIL this, you would wind up with 3m squared minus m minus 14. So your numerator is really 10m, parentheses, 3m minus 7, and m plus 2. There's 3m squared minus m minus 14 we just factored right here. So now we need to factor by grouping for the denominator. Factoring by grouping for the denominator, we have the 5m squared minus 4m minus 4. Trinomials minus minus. Therefore, you would have a plus minus. Product of a times c would be 5 or negative 5. You would take the product of AC, and it has to have a sum of b. So what times what would give us the 5 and would have a sum of b? So we want -4. So 5 and 1. So 1 has to be positive and 5 has to be negative. So when added together, so 1 times 5 is the 5. But we have a positive 1 minus 5, which would give us that -4m. And then you just rewrite the equation here, 5m squared plus 1m minus 5m minus 1. Again, group them. This negative is really a plus a negative, so plus a -5m. The first group, you can factor out an m, leaving you with 5m plus 1. The second group, you would actually factor out, you want the 5m plus 1 in the second group, so you'd factor out a -1. When you factor out a -1, you're left with 5m plus 1. Your two binomials would be m minus 1 and 5m plus 1. So back into your original equation up here, you'd have 10m, and this 5m squared minus 4m minus 4, we already factored by grouping. There it is. In this problem, we can take out 10m out of both numerator and denominator. Nothing else you can factor out, so you're left with 3m minus 7 and m plus 2 in your denominator, m minus 1 and 5m plus 1. You have to find out your excluded values. Your excluded values, well, you have 3 terms that have a variable, so you need to set those 3 terms equal to 0. 10m equals 0, m minus 1 equals 0, 5m plus 1 equals 0. In each case, you would solve for m. When you solve each of those equations for m, you would find out that m cannot be 0, m cannot be 1, and m cannot be -5. Our last and final example is recognizing opposites. In this first equation, I went ahead and rewrote it. So I have -t squared plus 36. What I did is, since this first term is negative, I factored out a -1. When I factored out a -1, I have a positive t squared minus 36. Here's what we've covered before. T squared minus 36, basically a squared minus b squared. You can write it as a plus b and a minus b. So when I factor this, I keep my -1. I have a and b, so t plus 6 and t minus 6. Your denominator, you can factor out a 5. And looking at this, we should be able to eliminate t minus 6, t minus 6, and we wind up with this simplified, which is -1 times t plus 6 all over 5. Excluded values, set your denominator equal to 0. Solve the equation, add 30 to both sides, divide both sides by 5, and we wind up with t cannot equal 6. This concludes Lesson 51, 9-2, Simplifying Rational Expressions.